So coming to the second question, that is, what is the time taken for the completion of a 3/4 of a first order reaction? So here a question is based on the first order kinetics. So the rate equation for a first order reaction is K is equal to 2.303 divided by T into log of concentration of A naught divided by concentration of A. Again, in this question, they are telling 3/4 of the initial concentration is completed. So if the initial concentration is taken as 1 means 3/4 completed means rest it will be 1 by 4. So final concentration left will be 1 by 4 of the initial concentration. So we can substitute in the rate equation, that is K is equal to 2.303 divided by T into log of A naught divided by 1 by 4 of A naught. That is final concentration become only left concentration is 1 by 4 of A naught. So 1 by 4 of A naught. Again simplifying, we will get K is equal to 2.303 divided by T log of 4. Again they are asking time. So we can rearrange this equation as T is equal to 2.303 divided by K into log 4. So that is the time taken to complete 3 by 4 of the first order reaction. So coming to the third question, that is, the half-life of a reaction is halved as the initial concentration of the reactant is doubled. Then what is the order of the reaction? So in this question they are asking the order of the reaction based on the T half. Again, T half for a zero order reaction is found to be T half is equal to A naught divided by 2K. That means T half is directly proportional to initial concentration of the reactant and inversely proportional to the rate constant of the reaction. Again, coming to the first order reaction, T half is found to be 0.693 divided by K. That means it is independent upon the initial concentration of the reactant. Again, coming to the second order, we found that T half is equal to 1 by A0 into K. That means it is inversely proportional to initial concentration of the reactant as well as the specific reaction rate. Here they are telling that is half-life of the reaction is halved when initial concentration of the reactant is doubled. So when inversely proportional to the initial, when T half is inversely proportional to the initial concentration of the reactant only, T half become half and A0 become double. So the order of the reaction can be second order. Coming to the fourth question, that is, a first order reaction is 75% complete after 32 minutes. When was the 50% of the reaction completed? So here also the question is based upon the first order kinetics. Again, first order kinetics means the integrated rate equation is equal to K is equal to 2.303 divided by T log of A naught concentration divided by A concentration. Again here they are telling 75% is completed. If you are taking A naught is equal to 100%, then 75% completed means 100 minus 75 means it is equal to 25% only left. So final concentration becomes 25. So substituting in this equation, we can get the value of the rate constant. Then only we can find out the T half. So T is found to be 32 minutes when it is 75% completed. So we can substitute the value of T is equal to 32. So K is equal to 2.303 divided by 32 into log of 100 divided by 25. 100 divided by 25 means it is equal to 4. So K is equal to 2.303 divided by 32 into log 4. Again 2.303 divided by 32 is equal to 0.0719 into log 4 is 0.6020. Again on multiplying we are getting specific reaction rate or rate constant as K is equal to 0.0432. Again unit will be here, it is time, it is minute. So it will come up, so it become minute inverse. And again concentration, here concentration unit will cancel, so it will become K unit become minute inverse. Again they are asking what is the 50% completion of the reaction. 50% completion means it is T half. Half of the reaction is completing means it is T half. So T half of a first order reaction is equal to 0.693 divided by K. K we have got it as 0.0432. So substituting this value, that is T50 is equal to 0.693 divided by 0.0432. That will be equal to 16.04. That is approximately 16 minutes. So T half is obtained as 16 minutes and K is obtained as 0.0432 minute inverse. So coming to the fifth question, that is the rate constant for the reaction 2N2O5 gives 4NO2 plus O2 is 3 into 10 raised to minus 5 second inverse. If the rate is 2.40 into 10 raised to minus 5 mole liter inverse second inverse, then what is the concentration of N2O5 in mole liter inverse? So in this question, they have given the rate constant of the reaction. That is, rate constant is found to be 3 into 10 raised to minus 5 second inverse. Again, we have got the general chemical reaction as 2N2O5 gives 4NO2 plus O2. First, we have to find out the rate law of this equation. To find the rate law, that is, first we have to check the unit of this rate constant. Here the unit given is second inverse. The general nth order reaction, for a general nth order reaction, the rate constant unit we have derived it as mole raised to 1 minus n, liter raised to n minus 1 second inverse. Again here if n is 1, then it becomes mole raised to 1 minus 1. 1 minus 1 means 0. So mole raised to 1 minus 1, mole raised to 0, that is equal to 1. Again liter raised to 1 minus 1, that is liter raised to 0, that is again 1. So then again second inverse left. So K can be second inverse when this n value, when this order is equal to 1. So here unit is obtained as second inverse. So the order of the reaction is 1 only. We can get the unit of rate constant as second inverse. So this equation follow first order kinetics. So the rate law expression for this reaction can be written as R is equal to K into concentration of N2O5. Again, R it is given, that is rate is given as 2.40 into 10 raised to minus 5 mole liter inverse second inverse. Again, rate constant is given 3 into 10 raised to minus 5 second inverse. Then we can find the concentration of N2O5. So concentration of N2O5 is equal to 2.4 into 10 raised to minus 5 divided by 3 into 10 raised to minus 5. That means 10 raised to minus 5 cancel. Again 2.4 divided by that is equal to 0.8. So it is equal to 0.8 mole liter inverse. So concentration of N2O5 for this reaction is found to be 0.8 mole liter inverse.